Okay, video for Rico, just talking about problems with low loss headers. So the concept of the low loss header is really intended for when the flows on the secondary side are greater than the flows on the primary side. It doesn't have to be that way, but that's the common use for low loss header. Also with ganged boilers. So just for my example, it's the one I posted up on the forum a little bit earlier. I've just picked some random flow rates to highlight the problem. So I've given a 40 litre flow rate in from the boiler into the header, and I've decided that my first circuit will draw off 30 litres per minute, and the second one 20, and the third 20. So it's a total flow rate of 70 litres per minute on the secondary and 40 litres per minute on the primary. So 40 litres comes in from the boiler, the first 30 litres of which go straight into our first circuit. That only leaves 10 litres left, which will be drawn into the 20 litre a minute circuit, and so it needs another 10 litres that has to be drawn from the return. So this is already a blended circuit, so we've already got a reduced temperature, 50 mix of return water and flow water from the boiler to satisfy the 20 litres. So the third circuit is actually not getting anything from the flow whatsoever. It's simply withdrawing its own return water, or a mixed return water from the other two circuits into that circuit. And I've seen this many times, people complaining radiators not heating up or underfloor heating not working, and this is the main cause. Of course, anything one side of a header is pretty much duplicated the other side. So here we have 30 litres coming in, which pretty much entirely goes to the boiler. It's mixed with 10 litres from the second circuit to go back to the boiler. 10 litres goes off this way to mix with this 20, and those 30 litres flowing this way have 20 here and 10 here. So how to avoid that? If you need to lay it out on that kind of header, if you were to actually put the two connections for the boiler in the centre here, then any surplus flow from the returns has to mix with our flow water, and so we get an equally mixed distribution temperature and the correct flow rate off to these three circuits. So that's a simple modification that will give you the correct performance. I haven't really thought that through as regards to if flows are lower on the secondary side than the primary side, and this isn't something I've ever done. I use the Viessmann kind of concept, which is 2 in, 2 out, so 40 litres in. So I've got a few arrows missing on this, so I'll just grab a pen. So on this one we have 70 litres return, 40 litres of which will go across there, and 30 litres up here, 30 litres going into there, mixing with 40 litres from there. So here we have a pure blend of water, 30-40, coming into this side, and equal distribution through this header. So one of the other things I was mentioning was velocity in the pipe here. So the point of a low loss header is that there's almost no pressure loss across this part of the system, low head loss, or low velocity. Sometimes you hear them be called low velocity headers, and sometimes low loss headers. More commonly is the low loss header. And the low loss is low head loss. And so as to get no head loss, which is no pressure variation across this, no delta P, we need a very low flow rate. And the various different sources give different flow rates. I use less than 0.3 meters per second, and I've seen it as low as some requiring it to be lower than 0.1 meter per second to get the low head losses. So if you look in the CIBSE design book, you'll see that for any given tube, the lower the flow rate, the lower the resistance, and this also goes on to the pump 2-4-8 relationship, where if you double the flow, you get 4 times the resistance to flow, and it requires 8 times the power. Try not to go off onto too many tangents. So if you want to size this header, you could do your mass flow rate. So and you'd come up with your litres per minute or litres per second, and your diameter is set by the formula ID is equal to 2 times the square root of 812.4 divided by target velocity multiplied by the flow rate in litres per second. And this 812 is pi divided by 1,000 or 1,000 divided by pi. Can't remember which way around it goes. Pretty certain it's 812.4. I'll re-clarify that later. I'll work it out just to make sure it's right. Target velocity for our header, 0.3 meters per second. Target velocity for a distribution header is 0.5 meters per second, and target velocity for a heating main pipe is 0.9 meters per second. So if you know these little bits of information, you use this formula, you can come up with the answer. So we'll clarify that one a bit later for you. The point of the low velocity in the distribution header here, which is at the 0.5 meters per second, is so you don't get any interaction or pressure loss across these points here, so that there's very little interaction between the pumps pulling on those circuits, and the same on this side when they return, and the low loss header here basically keeping the DP down across there. I hope that helps.